G'day guys. So I think last lesson we were looking at ways of representing numerical data, specifically frequency tables, percentage frequency tables, and histograms. Today we're looking at two other methods of representing numerical data. We're looking at dot plots and stem and leaf plots. Now, stem and leaf plots you've done, every single year for the last 20 years or something, but still students struggle with them, so it's important that we go over it. A dot plot, on the other hand, you may or may not have seen one of these, but this is basically the simplest form of graph that you can come up with. So I'm reading from here. I'm not even going to explain the paragraph that tells you what a dot plot is. You'll see what it is in a moment. Construct a dot plot showing the following data, which represents the number of hours worked by each of 10 students in their part-time jobs. So you've got 10 people, and this person works this many hours, this person works 9 hours, this person works 8 hours, and so on. So you identify your smallest number and your largest number, and then you create a scale over here just against the horizontal axis that extends from at least your smallest number to the largest number, maybe an extra one on either side just for good measure. And then depending on how many instances there are of that number in the list of values, so in other words, depending on the frequency, you draw a certain number of dots above the number over here on the horizontal axis. So how many 4s are there? There's 1 4. So I'll do 1 dot here. I'll change colors. How many 5s are there? Well, I'll go through from left to right. There's 1, there's 1. So 2 5s, so 2 dots. Make sure they're in rows, the dots this way, and in columns this way, just to keep things tidy. Do one more. How many 6s are there? 1, 2, 3, 4. So 1, 2, 3, 4, and so on. So they're dead easy, okay? And you tend not to use those for sets of data that are bigger than, 20, 10, something like that. They're not super common. It's the most basic sort of representation of some data you can come up with, really. Okay, stem and leaf plots. A little bit of general information first. So you'll remember that in a stem and leaf plot, you have a stem column and a leaf column. The stems are all of the digits except the last digit in the number. So that usually means first digit, because usually you do stem and leaf plots at high school and they're two-digit numbers. But if it was 365, then the stem would be 36 and the leaf would be 5, okay? And the stems basically are the same thing as a class interval on a group data frequency table, okay? So looking here for a moment before we actually do the problem, this stem here, that represents the class interval 30 to 39. And then as soon as a number is in the 40s, it belongs down here. So that's the class interval 40 to 49, and so on. Okay, so let's take a look at this particular question. Plot stem and leaf plots of the following sets of data. Use the class interval indicated in brackets. So class interval of size 10. Now if that said class interval of size 5, I would have a 3 here and then another 3 here, because I would need two class intervals within the 30s, 30 to 34 and then 35 to 39, okay, in two separate rows. But we're being asked for a class interval of size 10, so that's easy. So this is, you don't have to write this, but I'm just going to write it in to help you. That's 30 to 39. This is 40 to 49, 50 to 59, 60 to 69, and 70 to 79. All right, now you just start going through the numbers from smallest to largest. So how many in the 30s do we have? We have 31, 32, 33, in order as well, 34, 34. So 1, 2, 3, 4, 4, the second digit. So we're doubling up on the 3. And that was just a coincidence that they occurred in the list in the correct order. When they don't occur in the correct order, you have to put them into order. All right, so the 40s, what do we have? 49, 47, and 45. So in order, that would be 45, 47, 49. So 45, 47, 49. And we carry on in this manner until all of our numbers are crossed off. And they've all been accounted for here. All right. Now, very importantly, you have to do a key, because a 3 on the left and a 1 on the right could mean 31. It could mean 3.1. It depends on your data. So you need a key. All right. So that was our key for that particular example. And one thing to note is that if I put this on this, I'm trying to put it on the side, but you're not going to see that obviously. If you turn your head on the side and imagine that this is parallel, this line here, to the ground, you actually see a histogram. If these were columns, this is what the corresponding histogram to this data would look like exactly, which is pretty interesting. Okay, so here's a second example. And we're asked for a class interval of size 1. Well, what on earth does that mean? Take a look at the data, and they're all values with 1 decimal point, ranging from about 0.5, 0.2, I think might be the smallest, to about 4.9. So that makes sense that it would be a class interval of size 1. 0 to 0.9. 0 to 0.9, all those numbers belong in there. 1 to 1.9, all those numbers belong in there. 2 to 2.9, and so on. All right, so let's go. We're going to start with the zeros. What are the numbers that start with a 0? Okay, 0.2 is there. And where's the 0.5? Over there. So a 2 and a 5. Okay, all the numbers that start with a 1. 1.1, 1.7, 1.1, 1.1. So that was the 3 1.1s. There was a 1.7. And there must be a 1.8. Ah, there we go. There's my 1.8. And you continue in that fashion, and you have yourself a stem and leaf plot. And just a little bit down the bottom here, histogram, stem and leaf plot, or dot plot. Well, look, this isn't a rule at all. If you ever broke this rule, you wouldn't ever lose marks for it. You always just do the type of diagram you've been asked to do in the question, really. But here's a rough guide as to, depending upon how much data you have, which is more appropriate, a histogram, a stem and leaf plot, or a dot plot, because they all essentially show the same information. Well, here's a little guide. If the size of your data set is less than 30, you might use a dot plot. If it's between 30 and 50, you might use a stem and leaf plot. That's a bit unrealistic. That only gives you a range of 20. Would basically never see stem and leaf plots in that case. I'd say between 20 and 100 use a stem and leaf plot, and a histogram n greater than 50. Yeah, histograms do not work well for very low sets of data. Okay, guys, that is it for 2F. Good luck, and I'll see you next time.